So with the last set of notes, I didn't want to put the example in because that would have made the video way too long. So now we're going to do a practice problem looking at projectiles launched at an angle. So here we go. Erica kicks her soccer ball 12 meters per second at an angle of 40 degrees above the horizontal. What are the x and y components of the initial velocity? How long does it take to reach the maximum height? What is the maximum height? What is the maximum range? Etc., etc. So here's a picture of what's happening. If this is our horizontal, an angle of 40 degrees, and that's the path of our projectile. Again, I want this green line, and I want this blue line. So for the math problem for part A, what are the x and the y components? To find VIX, we are going to use V cosine theta, and to find VIY, we're going to use V sine theta. So VIX equals 12 cosine 40, and VIY equals 12 sine 40. VIX equals 10.39 meters per second, and VIY equals 5.99 meters per second. I do want you to write your t-chart in your notes. So over here, just to remind you, we have x and y, we have xi, xf, ax, vix, and vfx. yi, yf, ay, viy, vfy. And then we have 2 times. So xi is 0, viy is 0. Ax is 0, ay is negative 9.8. Now the vx's we automatically know, and both of these are the 10.39, and viy is 5.99. That's all the information that we have at this point in time, okay? So how long does it take the ball to reach its maximum height? On this diagram, our maximum height is here. So right now we don't actually have enough information to calculate this because we have 2 unknowns in the x direction and we have 3 unknowns in the y direction. But I did remind you about something about this location on a previous slide. I reminded you that the y component of velocity is 0 at that spot. So I actually do know this number in terms of answering question B. How long does it take the ball to reach its maximum height? Well, if I know that the maximum height has a velocity of 0, I can calculate for the time. Okay? So, I'm going to go back to my kinematics equations, and I'm going to use VFY equals VIY plus A times T. Because I have VFY, I have VIY, I have A, but I don't know time yet. So BFY is 0, VIY is 5.99, A is negative 9.8, and T is my unknown. I'm going to subtract over the 5.99. It's negative 5.99 equals negative 9.8 times T. And then I'm going to divide negative 5.99 by negative 9.8. And my time is 0.61 seconds. So I'm going to use that here. What is the ball's maximum height? So now I want to use my YF equals YI equation. Now on the previous set of notes, in the previous video, VIY was 0, so we could cross off this middle section. It is no longer 0, so I cannot do that anymore. So YF equals YI is 0, so I would write 5.99 times 0.61 plus 1/2 negative 9.8 times 0.61 squared. And remember, only that second 0.61 is squared. So YF equals 3.65 plus a negative 1.82. And YF equals 1.83 meters. So that soccer ball only made it 1.83 meters off the ground. Now for the next problem, what is the ball's maximum range? Range is how we indicate the horizontal motion. So right now we are looking for XF, but there's one more piece of information that we have not written in yet, and that is the time in the X direction. If we knew it took 0.61 seconds to go to the top of the path, we know it has to take 0.61 seconds to go back to the bottom. So our time in the X direction is actually 1.22 seconds. 0.61 times 2. So I'm going to solve for XF equals XI plus VIXT plus 1/2 AXT squared. And XI is 0, so I'm going to cross that out. AX is 0, so I'm going to cross out this last section because anything times 0 is 0. And we have XF equals 10.39 times 1.22. And XF equals 12.68 meters. So that soccer ball traveled 12.68 meters away. Now part E, with what velocity does the ball strike the ground? Now notice it doesn't say x velocity or horizontal velocity or vertical velocity. It just says total velocity. Well, looking back up here at this diagram, it's getting all drawn on, so I hope you can follow me. Whatever velocity we take off with here, we have to hit with here. So our final answer is just 12 meters per second, because that's the velocity that we kicked it with, so that's the velocity it's going to hit with. And at the very, very top, where I have this circle drawn, right here, this last question asks us, what are the ball's accelerations and velocities at the top of its rise? So we have V in the X direction and A in the X direction. I need to tell you both. V in the Y direction and A in the Y direction. I have to tell you both. Now, Vx never changes, so 10.39 all the time. Ax is 0 all the time. We can tell that up here in this diagram, in our t-chart. Vy, we use this for the second and third problems. Vy at the top of the path is 0 for a millisecond, but Ay is always negative 9.8 meters per second squared. Always, always, always. So if it asks you for the acceleration and the velocity, I want both directions, both variables. Okay? So this is a little bit of an involved problem. We are going to do another example in class tomorrow, and we are going to practice with this afterwards. So I'll see you in class, and we will get to work.